So we are going to look mainly at algebraic expressions. We're going to also look at components of algebraic expressions, and then we'll look at a few problems which are basic operations in algebra. What we're going to learn is we're going to look at algebraic expressions. We're going to look at the difference between an algebraic expression and an equation. Also want to look at components of algebraic expressions, what they are, and then basic operations involving algebra. In general, you'll notice that when we are talking about algebraic expressions, we are looking at expressions which have got this notation where one of them contains what we call an unknown, which is in this case a letter, and may also contain sometimes a number. We may have different numbers, like for example, we can have a mixture of letters and numbers. For example, on our board there, you can see that we have got different expressions. In the first one, we have y plus 9, which means that this is an addition. Okay. Then in the next one, we have 4d. 4d means it's 4 multiplied by d. All right. Then in the other one, we have 9 plus n. And we're going to look at that and why it matters. So in general, what we call an algebraic expression is a combination of variables, which are the letters like which we were looking at. Y there is a variable, D here is a variable, N is a variable. So those are the variables. Numbers, we have these numbers. 9 is a number, 4 is a different number, and this 9 again is another number. And then we have the operations. In this case, we have a plus and a division sign, and here there's an implied multiplication sign. Okay. Take note that when we're looking at algebraic expressions, we do not have an equal sign. All right. It is just an expression with no sign. So in simple, we may say that an algebraic expression is a mathematical phrase. All right. It's not a complete sentence in itself. It's just a phrase in which we use to communicate mathematical language. All right. So let's move on. Now we have these type of problems. These ones are different from your general algebraic expressions. You can see that they have a number. Like for example, in the first one here, we have 8. This is a number. Then we have R, which is a letter or a variable or an unknown. And now we have another sign which has been introduced, which is the equal sign. In this case, if an algebraic expression contains an equal sign, it is called an algebraic equation. All right. So we equate that algebraic expression to another value, which may be a variable or another expression, or maybe another number. It depends. All right. For example, in this case, our algebraic expression in the first one, 8 plus r, is being equated to 17, which is a number. Then we have t divided by 3, which is an algebraic expression being equated to 6, which is again another value. And we have 2n plus 8 being equated to 22. So you can see that the common thing is that all of these have got equations and unknowns. So these ones are called algebraic equations. All right. So what's the major difference between an algebraic expression and an algebraic equation? The most important difference to note is algebraic expressions are not solved. We only simplify them. Okay? We only simplify algebraic expressions. We do not solve them. However, algebraic equations, we solve them because we know that they are equal to something. Let's say, for example, 8 plus r is equals to 17, which means we can solve it. In this case, we have to use some rules which we use to solve algebraic equations, which are different from the way that we solve algebraic expressions. When we're solving algebraic expressions, we only simplify them. We do not solve them per se. For example, if they are like terms, what we do is we group them together, then simplify them, bring the like terms together, and then express it in an easier to understand way. All right, so let's move on. Now, when we come to algebraic expressions, we have some components which we need to note. We need to see what are some of the components of algebraic expressions. Some of them involve asking the correct questions. For example, the first question which we need to ask is, what is a variable? Secondly, we also need to ask ourselves, what is a coefficient? What is a coefficient and what is a variable? All right, so let's look at these in detail and try to answer them. All right, so to answer the first question, what is a variable? A variable is a symbol which we normally use, in which we normally use a letter, which is used to represent an unknown value. All right. So sometimes we may need to express or represent unknown values using a variable. Okay. So this variable may come in the form of any letter of the alphabet, A, B, C, D, the most common one being X and N. All right. So sometimes you may find an algebraic expression with these symbols. For example, it will be like 2n plus 3. All right. So this n is usually a common one. And then sometimes it may come in the form of x, like the common one, maybe x squared, okay, maybe x squared is equals to 4. This is an algebraic equation. This one is an algebraic expression. Right. So, for example, we may have a problem like, what is the variable in this expression, 9x plus 8? 9 is a real number. This x is the unknown letter, so it is our variable. Now, a coefficient, on the other hand, is a number which is written before the variable. Okay. So that coefficient, because it is written before the variable, it implies that the coefficient is going to multiply the variable. For example, in this number x, for all for all um, for all variables which have got no apparent coefficient, it means that the implied coefficient is x. So it's like, for example, in x here, the implied coefficient is 1. So for example, in O, let's say you just get a problem like just write a plus maybe 2n. In this one, the implied coefficient is 1, and here the coefficient is written, it's 2. Okay, so in this one, the coefficient is 1, and in this one, it is 96. Okay, now let's try a simple equation. We're given a problem. Jem places n number of oranges in 2 large boxes. Can you write an expression to represent the total number of oranges? Okay, this one is very simple. Identify the variable and the coefficient in the expression. So this one is quite simple. We can work it out quickly without having many problems. All right, so how do we work this one out? So Jem places a number of oranges in 2 large boxes. So how do we work that one out? So we know that n is the unknown number of oranges per box. So each box has got n number of oranges. Then the number of boxes in which these n number of oranges are placed is 2. So what we can do here is to multiply 2 multiplied by these n's. Okay, so we can say 2 multiplied by n, or just saying n plus n, which is equals to 2n. Now, in this expression 2n, 2 is the coefficient because it is the number, whereas n is the variable because it is the letter or symbol. All right. Next, we want to look at some basic operations in algebra. We want to look at addition, subtraction, division, and multiplication. All right. So, for example, in addition, we can have problems such as 4 more than x. So if number is 4 more than x, we start with x, and then our number will be plus 4. So when we see an expression which has got this keyword more, then it means that we're adding. Another expression, if it is a less kind of problem, whenever we see the word less, then it means that we must subtract. So 4 less than x now would imply the opposite, x subtract 4. Okay. If a question comes and asks us the quotient, all right, what it's asking us is for us to divide. So let's say it says the quotient of x and 4. What it's simply meaning is we normally take the first one that we've been given and make it our numerator, and the second one our denominator. So the quotient of x and 4 is x divided by 4, which is x over 4. Then sometimes we are given problems which involve products. So the product of x and 4 would be x multiplied by 4 or 4x. Now there are some rules concerning these algebraic expressions. If there's a number which is like a coefficient or a whole number multiplying an unknown, then it must come before the expression. For example, x multiplied by 4 does not give us x4, but it gives us 4x. Okay, that's some rule which we need to appreciate. Again, let's say, for example, if we have two expressions, like, for example, a multiplied by b, if we have such a problem, then our answer would be AB. We always write them in the order in which they appear on the alphabet or in the alphabetical order. So if we are given two unknowns and then we are asked to solve them, then we must always write them in the order of how they appear on the alphabet. Right, so now let's try to solve these problems. Write an algebraic expression for each phrase which we've been given. So we now want to convert ordinary language into mathematical language. Find the sum of u and 11. Okay, so I hope you've tried this one. Sum of u and 11 is u plus 11. That's very simple. Find an expression, an algebraic expression for 8 more than 5x. So our original number is 5x, and then we are adding 8. That's also workable. Let's try the next side. 8 more than the quotient of 9 and x. So let's start with the quotient of 9 and x. It's 9. The quotient of 9 and x is 9 over x. And the other number 8 more, we're going to add 8. Okay, so then 3 less than 8y. So 3 less than 8y, so it means the number is 3 from 8y, so it will be 8y minus 3. I hope you got that one right. All right, so let's look at how we can simplify algebraic expressions. Now, suppose you have a certain number of boxes of apples and oranges for which you do not know the exact quantities. How will you express it simply? If you want to express the total number of fruits, so the easiest way would be to combine boxes with the same fruit, so that you can be able to work them out. Let's say, for example, in our problem, we've got apples and oranges. So we need to take the apples, put them in a group of in the boxes which will label apples, and then we have the other boxes for oranges. Okay, so this grouping or this bringing of similar objects in one box is what we call bringing like terms together in algebra. So it is easier to work it like that because it makes the work much simpler and more obvious as compared to working with a soup of unknowns just scrambling about, and it will take too much time and very confusing to say the least. So it is easier to work with boxes of fruit which are the same, like for example we combine like terms like we have done here. All right, so now we want to try and simplify some algebraic expressions with whole numbers and some of them with decimals. All right, so the most important thing when we are doing this is to appreciate that the basic step which we need to do in all problems is to bring all like terms together. Okay, so now let's firstly look at what like terms are and what unlike terms are before we solve the problems. So if we are saying that terms are like, it means that they've got the exact number or the same combination of variables. For example, if there are terms in x, then it means that all terms must be in x. The exponents of the x must be the same, okay, for them to be characterized as like terms. So you can see here that the power of x is 1, the power of x is 1. So 8x and minus 11x are like terms in that they both have the same unknown and they have the same unknown with the same power on both expressions. Let's look at the second one. You can see here that even though the coefficients are different, here we have 2 over 7 and the other one have 4, yet the coefficients are the same. You can see that my coefficient is k to the power 3 and m to the power 5, yet k to the power 3 and m to the power 5. Again, in the other one, we can see that the coefficients are different as well, but the unknowns are the same. We have the unknowns being cv to the power 3, cv to the power 3, and hence they are like terms. We can solve them, we can add, subtract, etc. When now they are called unlike terms, it means that the terms have got either different variables or they may have the same variables but they have different powers. The first phenomena is very simple, 10r and 10s, even though the coefficients are the same, yet the unknowns are different with r here, with s here, so these ones are unlike terms, we cannot add them. The next one, you can see here that we have t to the power 2 and m to the power 5. Here we have t to the power 3 and m. So a better way to see this is to maybe like expand it. Say 2 over 7 multiplied by t multiplied by t multiplied by m, 5 m's like this, m, 3, 4, 5. Okay, on this side we have got 3 multiplied by t by t by t by m. We can already see here that we have 1t, 1t, 2t's, 2t's. Here we have 3t's, there's no more t this side. You can already see that these are unlike terms. Then the next one, this one is called g. This one doesn't have g, so these ones are unlike terms. All right, so let's try now to work problems involving like terms and unlike terms. Now to simplify, the first step is to identify like terms if we're given a problem. The second step is to rearrange and group them. The like terms you bring together, and then the other ones you also put on one side, and then you can operate, maybe add or subtract the integers or the coefficients of the like terms, then just maintain the variable. If the unlike term does not have anything else to add with, then just maintain it as it is. So for example, we've been given a problem here, 5x plus 4y minus 2x. So we have 5x plus 4y minus 2x. So in this one, we have a term in x, we have another term in x to the power 1 to the power 1. So it means that these ones are like terms, 5x and minus 2x. 4y is an unlike term. So what we do, we bring these ones together, 5x minus 2x. Then we just add this one. Take note that we also maintained the sign of this other like term. It is very important to watch out for the signs because they may change in answer if you do not watch or look at them properly. Right, so 5x minus 2x, we maintain the x, we're going to subtract the coefficients, 5 minus 2, we get a 3 here, and then we stay with our x. And the unlike term, we just bring it like it is, and we copy it down, and we maintain it as it is. So again, we may have problems where we need to simplify expressions with rational coefficients. For example, we have a problem with like 0.5d plus 1.4e minus 1.2e and 0.6d. So first step is to identify like terms. So this d and this one is together, this e and this one is together. So what I will do is 0.5d plus 0.6d plus 1.6e, so 1.4e, 1.4, 1.4 is 1.4e minus 1.2e. Okay, so 0.5 minus plus 0.6, this will give us 1.1g. Then 1.4e minus 1.2, this will be 1.4 minus 1.2. This will give us a positive 0.2e. Okay, so that will be our answer there, 1.1d plus 0.2e. Okay, right, this one is quite simple. All right, so let's move on. Our answer there is correct. We worked well, so our answer was correct. So let's look at another example. Maybe we may have a fraction. Our coefficient will be fraction. So in order to work with algebraic expressions which have got fractions, the first and most important step will be to first deal with the fractions part. To deal with the fractions part, you just need to convert the fractions into whole numbers. or multiply by the lowest common multiple of the denominators. So let's say, for example, you have this problem 2 over 3x minus 3 minus 1 quarter x. So in all whole numbers, the implied denominator again is always 1, because if we divide 3 divided by 1, we get 3. And then you look at the denominators now, 3 and 4. The lowest common multiple of 3 and 4 would be 12. Okay, so we're going to multiply everything by 12. We're going to multiply everything by 12. So 2 over 3 and 1 over 4, the lowest common denominator of them, lowest common multiple would be 12. So to convert now 2 over 3 as a fraction of 12, we're going to multiply it. How many 3's are in 12? 4. So to convert this denominator to get 12, we need to multiply by 4. So what we do on the denominator, we also do on the numerator. Now this 1 over 4, we need to also convert it to a fraction in 12. What we do for the denominator, we also do for the numerator. 4 to be a fraction, or how many 4's are in 12? We have 3. So we're going to multiply by 3 over 3. 2 times 4 gives us 8. 3 times 4 gives us 12. Then x. Then we're going to also have this one, 1 over 4x. 4 into 12, 3. So 3 times 1, we get another 3 here. And then we maintain our 3 over 1, because it's not going to be affected by these fractions. So we now subtract 8 over 12 minus 3 over 12x. Just subtract, since the denominator is the same, we just subtract the numerators, right? So 8 minus 3 gives us 5, so it will be 5 over 12x, and then we subtract the 3. All right, so take note of this one. If you have any problems with fractions, you can watch our other video on fractions. I think we get much help there. All right, so this about yes, so this has got our problems. Right, now let's say, for example, you've been asked to solve some problems and your life depended upon it, to open a key, and the only password which you had to solve were algebraic expressions. Okay, and you would then be able to find the key to your freedom. Okay, now simplify the algebraic expressions to get the password, and then put the correct letter which corresponds to the correct answer. So let's start with the first one. Here we're going to look for the simplest two. When we find their answers, then it will be very simple to eliminate the other ones. Right, 2x plus 3y minus 4x plus 5. So we find the like terms. The like terms in this one are 2x and minus 4x. These ones are unlike, we're going to just write them as they are. So 2x minus 4x, it will be rewritten as this. 2x minus 4x plus 3y plus 5. Okay, 2 minus 4 gives us minus 2x. So this one will be minus 2x minus 4, so minus plus 3y plus 5. Do you have a, yes, we already have this one. So 1 is t. Okay, then let's look at the other one. Minus 2x minus 2x minus 10.7y plus 13.7y minus 0.4x. So in this one, you bring the like terms together, minus 2.6x minus 0.4x. This 10.7y is also another like term with plus 13.7y. Right, so how do you solve it? Minus 2.6x minus 0.4x minus 10.7y plus 13.7y. Okay, this one is very simple. Minus 2.6 minus 0.4. It is the same as saying 2.6 plus 0.4, and then you maintain this negative sign, so it will be minus 3.0. Then minus 10.7 plus 13.7y is the same as saying 13.7, which is 3y positive. So our answer would be 3 plus 3y. Then answer like that. So minus 3x plus 3y. So yes, we have an answer like that. This one. So 2 is m. And then the last one, 1 over 2x. 1 over 2x plus 3 over 5y minus 1 over 3x. So this one is the odd one out. So we're only going to work with these two terms in x. So it will be half x minus a third of x, then plus 3 over 5y. Okay. So the lowest common multiple of this one, of this 2 and this 3, very simple. Lowest common multiple of 2 and 3 is 6. So we're going to multiply both of them by 6. So it will be 1 over 2 multiplied by 3 over 3 to get a fraction over 6. So 1 over 2 is the same as saying 3 over 6. And the other one, 1 over 3 times 2 over 2 to get a fraction out of 6, it will be 2 over 6. Okay, so here now, we're going to have 2 over 6 and 3 over 6. So we're going to now subtract 3 over 6 minus 2 over 6 will get 1 over 6. So if we subtract here, we're going to get 1 over 6. All right. All right. So do we have an answer that is 1 over 6? Yes, this one. And plus 3 over 5y, which is basically going to remain unchanged. So it will be T, A, M, A. Let's see if we got the correct answers. Yes. That's the correct order, T, M, A, and we've unlocked the puzzle. And we are safe. So in general, we've been looking at this. What are like terms? What are unlike terms? How do you combine like terms with different denominators? And what are the terms or the steps which we use in simplifying the algebraic expressions with the rational coefficients? We say that like terms have the same combination of variables, whereas on the other hand, unlike terms have different variables or have the same variables, but they have different powers or exponents. And the second question was, how do you combine like terms with different denominators? To combine them, you simply use the lowest common multiple of the denominators to rewrite the rational coefficients as similar fractions. Then you either add or subtract depending on what the question requires of you. Then the steps which you take in simplifying algebraic expressions: identify like terms, group them together, combine like terms using addition or subtraction, the unlike term, just maintain it as it is. All right. So here's some work for you to do. Express each an algebraic expression. All right. So less than 25 multiplied by a number n. So 25 multiplied by a number n, and then less 8. Right, so it will be 25n minus 8. It's very simple. 7 more than the quotient of 26 and the number n. So 26 over n plus 7. That's very simple again. All right, let me try on a different color here. 3 more than the difference of 20 and a number x. So we have 20, so bright. Let me use blue here. So we have 3 more than the difference of 20 and the number x. So 20 minus x, and then whatever we get, we add 3. A number s plus 45, this one is very simple, s plus 45, very simple. 5 times the product of a number x and 8. Okay, so 5 times the product of 8 times x, which is equals to 5 times 8x. Okay, which if we multiply will just give us 40x. 9 more than a number w, this will be w plus 9. 4 times the sum of 41 and number y. 4 times, so we're going to put brackets instead of multiplying, the sum of 41 plus y. Then 5 less than the quotient of a number n and 16. So n over 16, and then minus 5. Take note that it's different here and here. The first number that appeared was 26. That's why we made 26 the numerator and n the denominator. In this case, n appeared first, so we wrote n as the numerator and 16 as the denominator, and then we subtracted this 5. 7 less than the difference of 22 and the number n. So 22 minus n, then minus 7. And then the last one, 5 times the sum of a number u and 15. So 5, instead of times, I'm going to put brackets. The sum of a number u plus 15. Okay, so these are our solutions to our problems. I hope you have been following through. I'll just leave them for a few seconds so that you may be able to copy the solutions and appreciate them. And then we can look at the last things before we close this presentation. All right, so I hope you've been able to note down the solutions. Again, we have a few more problems. Now we need to solve these ones. These are, instead of the algebraic expressions which we were doing in the previous one, we're going to look at now algebraic equations. Right, so 4x is equals to 36. What we do here, whatever we do on the left, we also do on the right. So we want to make x the subject of the formula. We'll talk about this in another video. So to make x the subject of the formula, we divide both sides by 4 so that we only remain with x on one side. 4 into 4, 1, 4 into 4, 1, 4 into 4, 1, 4 into 36, 9. So x will be equal to 9, okay? 11x is equals to 121. This one is easy, right? What do we do? What's the common factor? 11. So we divide by 11 this side, we divide by 11 that side. 11 into 11, 1 into 11, 1. 11 into 11, 1. 11 into 12, 1 remainder 1. 11 into 11, 1. So x will be equals to 11. Now we have a fraction. A fraction previously. So the simplest way to deal with the fraction is to use that method which we tried. So we multiply by the denominator of the fraction. That will be the simplest way to get rid of this fraction. So 6 into 6, 1, 6 into 6, 1, 3 times 6, 18. So x is equals to 18. Let's look at another one. Equals to 48. So we're going to divide both sides by 2, divide by 2, 2, 2, 2, 1, 2 into 2, 1, 2 into 4, 2, 2 into 8, 4. So x is equal to 24. So you can see that algebraic expressions are, you give them enough time and enough practice, you'll be speaking this language of mathematics quite fluently, I think. All right, let's look at the last two here. We have 7x is equals to 21. So to make x substitute the formula, we're going to divide by its coefficient, which is 7. 7 into 7, 1. 7 into 7, 1. 7 into 7, 1. 7 into 21, 3. So in this case, x is equals to 3. And then in this one again, we have a fraction. So we're going to multiply by the denominator of the fraction. 7 into 7, 1. 7 into 7, 1. Here we're going to multiply by 7. So x is equals to 9 times 7, which is equals to 63. Okay. So if you have any problems, just ask in the comments. Just leave a comment and we'll be able to help as soon as we can. All right, so if you do not have a problem, I'm going to give you a problem. So I have a problem with me here. 3 bracket 5x minus 2y minus x plus 2y. What is the simplified form of this algebraic expression? Please share your answers in the comments below. Share your answer in the comments below. Feel free to write the answer which you want because all answers are correct answers. All right, so this about sums up our discussions on algebraic expressions. Please feel free to ask questions. Remember to like, remember to subscribe and share. Thank you for watching. We are going to meet you in the next video. All right. Hello everyone, welcome. In this video, we are going to be looking at factorization. So a brief recap, we're going to look at factorization basing on what we've already covered. We've looked at expansion of brackets. Now we're going to look at the opposite. Look at this one, for example, 2 bracket 4x plus 3. To expand it, we're going to multiply 2 and 4x and also multiply the 2 with the 3. So this 2, because it is outside of the bracket, means it's going to approach or multiply every term in the bracket, multiplied by 4x, and also add 2 multiplied by 3. Then here we get 8x plus 6. So this is what we were doing when we were looking at expansion of brackets. So what do you see here? What's the commonality between 8x and 6? Okay, so if you can see here, there's 8 and there's 6. These are multiples of 2. Okay, if you look at the brackets here, you can see there's a 2 in the first bracket, a 2 in the second bracket. That 2 is the common factor. So this is the 2 in which we had as the coefficient of the brackets in the first problem. This is why when we expand, we get our answer as 8x plus 6. The important thing when factorizing is to appreciate or to look for common factors. All right? Like if you look in this example, there is 2 multiplying everything. So if the common factor here is 2, multiplying 4x and multiplying the 3. So 2 is the common factor. That's the one which we factor out. Okay, let's try another example and see. Okay, so we continue. Factorize the following. In this one, I'm going to give you the expression 2x plus 12. 2x plus 12. So it's very simple to factorize this one. The most important thing is to look for the common factors. You look at 2x and 12. So the common factor there, you need to break down the number into parts, all right? 2x can be written as 2 multiplied by x, and 12 can also be written as 2 multiplied by 6, all right? So what is the common factor now there? The common factor, there is a 2 this side and there's a 2 the other side. So 2 is the common factor. We write it outside the brackets. Then we add the remaining factors, x, and then plus, maintain the sign, 6. So our answer is therefore 2 bracket x plus 6. Alright, let's try the next one. 3x plus 15. Who wants to try? So here what we'll do is we're going to express 3x as 3 times x and 15 as 3 times 5. Right, and then we factor out the 3, which is the common factor. The 3 here, 3 there, it's common, and then we add the remaining factors, x plus 5. Next problem, let's look at the next problem now. 5y minus 15. Alright, so to solve this, we look for the common factor, which is 5. Then we're going to say 5 multiplied by y, and then we subtract 5 multiplied by 3. So our common factor there is 5. So we're going to factor 5 out and write 5. Then in brackets we're going to add the remainders, y minus 3. So that will be our final answer there. Let's look at the example. Next one, 4y minus 28. So in this example now, we are going to factor out 4, so it's going to be 4 multiplied by y minus 4 multiplied by 7. You've seen that we looked for a common factor which can be a factor of both this 28 and this 4y, and it is 4. So we'll factor out the 4 and then right outside the brackets it's going to be 4. We're going to take this 4 bracket y minus 7. So that will be our factorized form. Alright, let's continue to look at the examples. So now we want to look at how we can factorize powers higher than 1. Factorizing powers higher than 1. We're only looking at the powers of x, or of the unknown only being 1. Now we want to look at how we can factorize if there are powers of x higher than 1. Alright, so 3x squared plus 3 plus 15x, we can break it down to 3 multiplied by x plus 3 multiplied by 5 multiplied by x. In this way it will be easier to solve because we've broken down the problem. Now we need to isolate common factors from both the expressions in the brackets. So here we can see that we have a 3 this side and also in an x. We have a 3 this side and an x. So we can also see here that there's a 3 and an x on the other side. Alright, so we factor out the 3 and we also factor out the x and we multiply them together, and what will remain are the x and the 5, which we are going to add in the last step. So our answer will be, we have something like 3 this 3 and this x as the common factors, which we will say 3x, multiplying or putting in brackets. So we cross out those ones which we've factored out. The remaining factors are x and positive 5. So our factorized form would be 3x bracket x plus 5. Alright, that is easy enough, right? The next example, 4x squared plus 12x. Again, the trick here is to find some apparent commonality before you even attack the problem. You can see here that there's 4 here and there's 12. These are both multiples of 4. Break it down to its smallest, but here we can already see that we don't need to multiply 2 by 2 because the highest common factor here is 4. So now we're going to break it down like this. It's going to be 4 multiplied by x multiplied by x plus 4 multiplied by 3 multiplied by x. Right? Very simple here up to this stage. Then this 4, there's a 4 here, there's a 4 there. So it means amongst our common factors, there's a 4. There's an x here, there's an x there, which means an x is outside of the brackets. No further x this side, no further 3 this side. So it means we toss out the common factors 4, 4, x, x. We remain with x plus 3. X plus 3. Factorize like this. Let it be like example C. 12a plus 8ab. Factorizing something like this is very, very simple. We can already see in our mind's eye that these are multiples of 4. So we can factorize this in 4 multiplied by 3 multiplied by a plus 4 multiplied by 2 multiplied by a multiplied by b. Like this. In my mind's eye, I can almost see what's happening here. There's a common factor 4 there. So the answer is going to be 4. There's an a here and an a there. We write it as another common factor. No more common factors. So the remaining factors will be 3 plus 2 multiplied by b, which is 2b. Alright, then we move on to our next example. So we're going to have the last example. 3e squared plus 4e plus ef. So you can see that e is appearing in all equations. We break it down 3 times e plus 4 times e plus e times f. Alright. You can see here in our expanded expression, we do not have 3's in other expressions or 4's, but we only have e. We have e, and e there. So we factor out e, cross it out. Then we are left with 3e plus 4 plus f. And that is the end.
Oh, so you first take out all the common factors.
Yes, the highest common factor.
And then the remaining?
Don't forget to comment, like, and subscribe. Enjoy. See you in the next video. Hello, welcome. In this video, we are going to look at factorization and then later on move on to constructing and solving equations. So sit tight and enjoy. If you have got any questions, please feel free to ask in the comments below. Don't forget to subscribe. 3x squared plus 15x. The other one, 4x squared plus 12x. The other one, 4x squared plus 10x. The other one, 15x squared plus 5x. Right? So, in this problem, it was very simple. Just needed to find a common factor. In this case, it will be 3x. Then bracket x plus 5. The second one, it was 4x. Bracket x plus 3. The other one, 2x. Bracket 2x plus 5. And the other one, 5x. Bracket x plus 1. Right, so you needed to make those ones. If you make it correctly, give yourself a mark for each. Right, let's move on to question 9. Factorize each expression. So this is 8a, b, c, and d. C, d. Question 9a. 7m squared plus m. Right? The common factor here, let's just list all of them so that we do them once and for all. 5a squared minus 15a c t squared minus plus 9t d 8h minus 4h squared e 3y plus 12y squared. Let's f 12y minus 16y squared, right? G 16e squared plus 8e, and h 15e plus 6i, right? So this was a very simple exercise. Give yourself 1 mark for each correct answer here. The common factor here was m bracket 7m plus 1. Second one was 5a, just mark correctly, 5a bracket a minus 3. The third one was t bracket t plus 3 plus 9, sorry, t plus 9. Then the fourth one was 4h bracket 2 minus h. Yes, right. The fifth one was 3y bracket 1 plus 4y. The next one, this one, 12y minus 4y bracket 3 minus 4y. Then the next one was 8e bracket 2e plus 1. Then this one now, you see that the commonality was not in the unknowns, but in the coefficients. So the common factor will be 3 bracket 5e plus 2i. Okay, so here you notice that, for example, this question 8a bracket 2a plus 1, 4a and 4a plus 2 in brackets will not work because there's still some commonality, which means you need to take the highest common factor, which is 8. So you need to take 8. If you write it like this, 4a bracket 4a plus 2 is not correct because 4a and 2, they still have some commonality, a common factor between them, which is 2. So you need to factor out that 2 again, multiply it by 4, and you get your 8. Alright, so take note of that to use the highest common factor. Okay, let's move on. So here we see that the common factor was 7c. So we write 7c bracket 2d minus 1. In the second, we see the common factor was 4a. So we write 4a bracket 3 plus 2b. In the third one, we had the common factor being 3g being multiplied by 7 plus 5h. Alright, 3g bracket 7 plus 5h. And then the fourth one, the factorized version was 15w bracket 2 minus t. Alright, so these are the solutions for the problems that we have up to now. We can see here that there is no h here, so it would mean that in the solution we do not need to add an h. Yes.
2 minus 1t?
Yes. But last time I said that if we have 1 as a coefficient of an unknown, we might as well ignore it. But let's move on to number 11, the last one. Alright, so we're going to swiftly move forward. Copy and complete each factorization. 11. Okay, so we move on to number 11a. The first one was 2a plus 4h plus 8. The second one was 5b minus 25 plus 5j. C, 12tu plus 16u minus 20. Okay, then for D, it was 3e squared plus 4e plus ef. And E, 7k minus k squared minus ak. And then the last one was 6n squared minus 9n minus 3mn. We'll go to the solutions now. Here the common factor was 2. Bracket a plus 2h plus 4. This one, the common factor was 5. Bracket b minus 5 plus j. Third one, common factor was 4. Bracket 3tu plus 4u minus 5. This one, D, the common factor was E, bracket 3e plus 4 plus f. For E, the common factor was K, bracket 7 minus K minus A. Then F, common factor here was 3n, bracket 2n minus 3 plus n. Right. Alright, now we're going to look at constructing and solving equations. Constructing and solving equations. Alright. So in order for us to construct and solve equations, we must be able to be in a point to be able to separate them from expressions which we were doing before. So here are some things to remember when we are working with equations. We've looked at expressions before. Now we need to see if there's a difference between equations and formula and expressions. So a formula is a rule. A formula is a rule. A formula is a rule which shows the relationship between two or more variables or unknowns or quantities. It must have an equal sign and must have an equal sign. So this shows that you have a formula. It must have an equal sign. Alright. A classic example would be the formula for finding the force exerted by an object, which is given by the formula force equals to mass multiplied by acceleration, of which, whilst on Earth, the acceleration due to gravity would be 10 meters per second squared. The formula can be summarized as F equals to ma, force equals to mass multiplied by acceleration. On the Earth, the formula is F is equals to mass times 10 because we round off the acceleration due to gravity to 10. On the Moon, it is 1.6 meters per second squared. So it will be any mass times 10 meters per second squared. 10 meters per second squared. So this is the formula which we use for calculating the force. Alright? Alright. So next we want to look at expressions. An expression is a statement. An expression is a statement which involves one or more variables. Okay? It may have maybe just terms in x or terms in x and y. That's one or more variables. But the other thing to note is that it does not have an equal sign. It does not have an equal sign. So an expression is just any general statement. A squared plus 2b, 3x minus 7, 2x plus 1, or the one which I'm going to write here, 2x plus 3. 2x plus 3. This is an example of an expression. It has got one unknown term, which is x, and it has got another term, 3, which is a constant. Alright, so let's move on. When we talk about equations now, it is an expression. An equation is an expression that has two or more unknowns and also has an equal sign, but the major differentiating factor or differentiating factor between an equation and a formula is that the equation can actually be solved to find the value of the unknown number. So an equation is an expression with an equal sign and can be solved to find the value of the unknown. In this case, let's say for example, 2x plus 3 equals to 0. Alright? So to solve this is very simple. It's a very simple equation, 2x plus 3. A very simple equation. So you notice that even if the formula is an equal sign and two or more unknowns, yet the problem is that it has got, these unknowns do not have values, they have got assigned values. Whereas in equation, the unknown actually has a known value. The only thing which we need to do is to calculate the value of the unknown. Okay? So when we have equations, we say that we want to solve the equation to find the value of the unknown. So we say we solve for x or solve for y or whatever the unknown is, solve for x. Whereas in a formula, we need to assign it values. Let's say, for example, calculate the force when the mass is given this number and the acceleration is given this number. In contrary to equations where we just have to solve and find the value of the unknown, which is
Let's move on to try out a few examples.
So here I'm going to write the equation. I'm going to write my equation which we will need to solve here. We're going to try it out together. Alright, so as soon as I'm done writing, we'll work it out together.
Now, take note. In solving equations, we need to follow steps, okay?
We need to have a methodical way of doing it, alright? So in this example, we have 3x plus 5 is equals to 26. So what we will need to do is...
So for us to solve this problem, we first need to have one side, we need to bring like terms together. All terms with x on one side, all terms without x on the other side.
To do that, we subtracted 5 from both sides, 5 from both sides. That's what we did. So that our equation remains balanced. Now we have 3x plus 5 minus 5 is equals to 26 minus 5.
For your own information, this cannot add or subtract. Why? They've got differences in the unknown. This is x to the power 1, this is x to the power 0. So we cannot work them out. Right. So 5 minus 5 gives us 0. So this will be 3x is equals to 26 minus 5, 21. When we get to this stage, what do we do? Since the coefficient of x is 3, we're going to divide both sides by 3. So we're going to say divide by both sides.
21 divided by 3 is 7.
So 3 into 3, 1, 3 into 3, 3 into 3, 3 into 3, 1, 7. So x is equals to 7.
7, yeah.
This is the solution for the problem. What it means is if we substitute this x into this equation, the left-hand side will be equal to the right-hand side. Right. So I want to explain why we are subtracting 5 from both sides. This is an equation, right? An equation means that it's like a seesaw. And it's balanced on both sides. Okay? This is maybe 26 on this side, this is 26 on this side. Right? So it's balanced. Now, if we want to maintain this balance, if we add 2 kilograms on the left side, what should we do on the right to maintain the balance? Yes, also add 2, right? If we want to keep it balanced and we subtract 5 from the left hand side, what do you do on the right?
Subtract 5.
Yes. So this is why we are treating our equation like this. We want to maintain its equality, right? So if we subtract 5 from the left side, we also subtract 5 from the right side of the equal side. If we divide by 3 on the left side, we also divide by 3 on the right side. Whatever we do on the left hand side, we also do on the right so that it maintains its equality. Right, B 4 bracket x minus 3 equals to 24. Let's try this one.
Alright, so here I will show two methods for solving these problems. Method A, method B. Okay, so you are going to choose the one which seems similar to you. Alright, so here we have 4 bracket x minus 3 equals 24. And here we have 4 bracket x minus 3 equals 24. Alright, so here the first method, method A, you can see here that both sides are multiples of 4. I have 4 on the other side and 24 on the other side. So 4 and 24 are multiples of 4. So I divide by 4 on the other side, 4 on the other side. Divide by 4, I get 1. Divide by 4, I get 6 there. So my simplified problem would be x minus 3 equals to 6. And now it's simple. To solve it, I just add 3 on both sides. So it will be x minus 3 plus 3 equals to 6 plus 3. 3 minus 3 is equals to 0, so x is equals to 9. Okay, the second method, method B, what we will do is very simple, is to expand. 4 will multiply the x and 4 will also multiply the minus 3. So it will be 4x minus 12 is equals to 24. Then we add 12 to both sides so that we have one like terms on the same side. 4x minus 12 plus 12 equals to 24 plus 12. Then these 12 will cancel out each other. So remember the seesaw example. So no worry about those ones. So now we continue. 4x minus 12 plus 12 gives us 0. So it will be 4x equals to 24 plus 12 equals to 36. We divide both sides by 4. So that we remain with x on one side. 4 into 4, 1. 4 into 36, 9. So x is equals to 9. Which method is easier for you here?
I go for two. I go for B. I go for B.
Right. Very simple stuff, right? Yep. So you see, I've used two methods, but I still arrived at the same answer. What it means is you may develop a thought process which may be different even from the teacher's suggested methods. However, you still get to the correct answer. If I can still follow through with your method and you get to the correct answer, no problem. Let's try question C. Y over 4 minus 10 is equals to 1. Boom. Let's go.
Alright, so to solve this one, we are going to use two methods, method A and method B. Alright, so you can see here that we have a fraction part, y over 4. So we need to eliminate that fraction part first. Y over 4 minus 10 equals to 1. So what we'll do is method A, y over 4 minus 10 plus 10 equals to 1 plus 10. We add 10 on both sides. Then we get y over 4 is equals to 11. Okay, so you can see here we still have the fraction part. We need to eliminate it. What we'll do is we'll multiply both sides by 4. Multiply both sides by 4. Then it becomes y is equals to 44. Very simple method, right? The second method is also simple, but it is a longer method. We need to remove the fraction part of our y over 4 and then multiply everything by 4. Alright? Okay, so you can see here that when we go to y over 4, we multiply it by 4, and whatever we do on the left hand side, we also do on the right hand side, so that we get the same answer there. Alright, remember they are equations, so we treat them the same. Right, moving on to second method, method B. So you see that we have a fraction in our equation. The first thing when you encounter fractions, you need to eliminate this fraction part. What I'll do is I'll multiply everything by 4, which is the denominator for the fraction, which will give us y over 4 times 4 minus 10 times 4 equals to 1 times 4. Okay, and then what we have here, these ones will cross each other out. 4 and 4 will remain with y minus 40 is equals to 4. And then we are going to add 40 on both sides to remain with y on one side. Y minus 40 plus 40 is equals to 4 plus 40. And then that one will give us a 0. We will remain with y is equals to 4 plus 40, which is y equals to 44. Which method is simpler? Which one do you think is simpler here? A or B? If you have questions, you can ask in the comments below. Don't forget to like, to comment, to subscribe, and to share. And please get in touch with us for more videos like this, or if you've got questions which you want solved. Thank you. See you in the next video. Hello everyone, welcome. In this video, we'll be looking at how we can solve equations in very simple and easy to understand methods. So enjoy. Alright, so in the first question, we're looking at 2x plus 1 is equals to 11. We want to try and solve this simple problem. Alright, so the first step that we're going to do is we want to put all like terms on one side. 2x plus 1 minus 1 is equals to 11 minus 1. We'll subtract 1 from both sides, leaving us with 2x equals to 10. We divide both sides by 2. We get x is equals to 5. That's a very simple problem. Alright, so a thing to note here is that whatever we do on the left side, we also do on the right hand side. So we move on to the second one. The second problem is 5x minus 2 is equals to 18. What we will do is very simple. We're going to add 2 to both sides, so it will be 5x minus 2 plus 2 is equals to 18 plus 2. Then it will be 5x is equals to 20. Divide both sides by 5. X is equals to 4. Very simple again. Thing to remember is that whatever we do on the left side, we do on the right side, so we maintain the equality of the equation.
Let's look at the third one. 3 bracket x plus 4 is equals to 2. In this one, you can see that both sides have got multiples of 3. So a very simple method, we just divide both sides by 3. We remain with x plus 4 is equals to 7. Then we subtract 4 from both sides. X plus 4 minus 4 is equals to 7 minus 4. Then it will be x is equals to 3. A very, very simple way to do it. Okay. Next, we move on to question D. X over 4 minus 1 is equals to 5. We can see here we have a fraction part. So we need to remove the fraction part. Either we can multiply everything by 4 or subtract 1 from both sides, add 1 to both sides and then multiply by 4. So we'll do the multiplication one. So here what we'll do, we'll write x divided by 4 times 4 minus 1 times 4 is equals to 5 times 4. Take note that we did the same thing to everything so that it remains equal. So it will be x minus 4 equals to 20, and then our x is equals to 20 minus 4 plus 4, which is equals to 20 plus 4, and then x is equals to 24. Alright, that's fair enough. I hope you are following and not having problems. In our next problem, we have a rectangle. We want to solve some algebraic problems which involve rectangles. One side, which is long, is 3x plus 2. The other side is 26. The other short side, the other one side is 15. Then the other side is y over 2 plus 5. Alright, so here you're going to use common sense and logic and knowledge from other topics. You know from your knowledge of shapes that a rectangle has got two sides which are long and equal and two sides which are short and equal. So we have two long sides which are long and equal, and we have two short sides which are also equal. So what we'll simply do is we're going to equate the two sides which are long and equal and equate the two sides which are short and equal, and then we'll find our answer there. Alright, so what we're going to do, we're going to just equate 3x plus 2 is equals to 26. Then we subtract 2 from both sides. 3x plus 2 minus 2 is equals to 26 minus 2. Then 3x is equals to 24. Then we divide both sides by 3. X will be equal to 8. Okay, very simple solution. So that will be the solution there. Alright, then to solve for y, we're going to say y over 2 plus 5 is equals to 15. Okay, so we're just going to multiply everything by 2. Y over 2 times 2 plus 5 times 2 equals to 15 times 2. Okay, this is an expanded form of the problem, which is easier to solve. These ones cancel each other out. We remain with y plus 10 equals to 30. Alright, y plus 10 minus 10 equals to 30 minus 10. Then we remain with y is equals to 20. Okay, then we move on to the next one. 4 bracket x plus 2 is equals to 40. Alright, so you can see again that in this question both sides have got multiples of 4. 4 and 40 are both multiples of 4. So what we'll simply do, we'll divide by 4 both sides, and then we remain with x plus 2 equated to the answer which we get on the right hand side. Alright, so what we'll do is we're just going to divide by 4, and then we solve quickly and easily. So this side, left hand side divided by 4, right hand side divided by 4, it will be x plus 2 is equals to 10. Then we subtract 2 from both sides to maintain the equality. X plus 2 minus 2 is equals to 10 minus 2. Then x is equals to 8. Very simple. Let's try a different problem. 6 multiplied by y plus 3 is equals to 30. So in this problem, we're going to try a different method so that we can get acclimatized to different methods. So in this one, we're going to expand. 6 is going to multiply y and also going to multiply 3. And then we equate everything to 30. bring like terms together, solve. 6y plus 18 is equals to 30. Then 6y plus 18 is equals to 30, like this. We subtract 18 from both sides. I'll divide everything by 6. It depends with what you want to do from here. For me, I'm going to subtract 18 from both sides. 6y plus 18 minus 18 is equals to 30 minus 18. Alright, so what we'll do next is we'll get 6y is equals to 12. Then we divide both sides by 6 so that we remain with y, and then we get y is equals to 2. Alright, so we can use many methods, but they will bring us to the same answer. We move on to another one. Another problem which we might have is this one. Sometimes when we are working with, let's say, question papers, we are given hints or a method which to follow through, like in this one. 4x plus 5 is equals to x plus 17, and we are given a hint we should subtract x from both sides. Alright, so if we are to subtract x from both sides, then we should use that so that we do not fail the exam. 4x minus x plus 5 is equals to x minus x plus 17. We've subtracted x from both sides. Here we remain with 3x plus 5 is equals to x minus x is 0. So here we just remain with 17. Then here it's easy to solve. 3x plus 5 minus 5 is equals to 17 minus 5, which gives us 3x is equals to 12. We divide both sides by 3, and we remain with x is equals to 4. Okay, so you've seen we've now used a different method, but the answer is still workable. Okay, we still reach the answer in a good way. Alright, so we're going to try out another one using hints from the question. In this case, we're asked to calculate 7x plus 2, which is equals to 2x plus 27, and then we're asked to subtract 2x from both sides. So it will be 7x minus 2x plus 2 is equals to 2x minus 2 plus 27. Right, so this will be 5x plus 2 is equals to 27, since 2 minus 2 is equals to 0. Right, then we subtract 2 from both sides. 5x plus 2 minus 2 is equals to 27 minus 2. Then we will remain with 5x is equals to 25. We divide both sides by 5 to maintain the equality, and we remain with x is equals to 5. Alright,
Is equals to 5 then.
Alright, let's try out another problem. In this case, we are given the problem 10x minus 4 is equals to 8x plus 12. The hint is to subtract 8x from both sides. This makes the work easier for us. So what we'll simply do is we'll subtract 8x from both sides. Then it will be 10x minus 8x minus 4 is equals to 8x minus 8x plus 12. So 10x minus 8x equals to 2x minus 4 is equals to 0x plus 12. So now it's easier. We add 4 to both sides. 2x minus 4 plus 4 is equals to 12 plus 4. Minus 4 plus 4 gives us 0. So here we remain with 2x, because minus 4 plus 4 gives us 0. So here we have 2x is equals to 12 plus 4 is equals to 16. We divide both sides by 2. We remain with x is equals to 8. Okay. Alright, so let's try out another one. We're going to go back to that one. 4x plus 5 is equals to x plus 17. Alright, so we just want to look at the problems where we are given a hint to explain what it means. So here you can see we've got x on one side and x on the other side, the same unknown but on two different sides. So the thing that we want to do here is we want to bring all like terms on one side, all terms with x to the left side, and all terms without x to the other side. Alright, Okay, so you can see here this equation where we have just one unknown but separated into two different sides. So to be able to solve this kind of problem, we need to collect like terms, put them on one side, and the other like terms, we put them on the other side. In this case, we need to bring terms with x on one side, terms without x on the other side. So remember this thing that we need to bring all like terms together. When solving equations, always bring all like terms together. Okay, this is a key thing to remember here. So the terms in x, we are going to bring them to the left, and the terms without x, we're going to take them to the right. So 4x minus, so in order to do that, we are going to bring the terms with x on one side. So we're going to subtract x from both sides. So we're going to say 4x plus 5 minus x is equals to x minus x plus 17. The overall effect of subtracting x from the left side and x from the right side means that the equation remains the same. It maintains its equality. Whatever we do on the left hand side, we must also do on the right hand side so that the equation remains balanced or equal. So this is how we solve equations. Now we rearrange so that we can work them out. The like terms, 4x minus x plus 5 is equals to x minus x gives us 0 plus 17. So 4x minus x gives us 3x plus 5 equals to 17. This gets you halfway done. We've come now to a form which you understand. Now we need to continue with this form and solve our equation. What we did was the long version. The short version is to just say subtract x from both sides like the hint given in the question, and then we solve it like that. Alright, so you saw that we needed to bring all the like terms together, the terms with x on the left side and the terms without x, we take them to the right side. Now to solve the equation is very simple from here onwards. We're just going to use our method of subtracting 5 from both sides. So 3x plus 5, we subtract 5 from the left, we also subtract from the right so that our equation remains its equality. Alright, 3x plus 5 minus 5 is equals to 17 minus 5. So 5 minus 5 is 0, 3x is equals to 12. 17 minus 5 is equals to 12. We divide both sides by 3. X is equals to 4. X is equals to 4. Alright, I've shown you many methods. You choose the one which works best for you. Enjoy, happy working. If you enjoyed this presentation, don't forget to comment, to like, to subscribe, and to share. See you in the next video.
So to solve this, you just need to look at these numbers. So here you need to look for factors of 63, which are also going to give you a sum of 16. For example, 63 can be expressed as 9 multiplied by 7. Okay, so now you need to see which factors of 63 give you a sum of minus 16. So 63 can also be a product of minus 9 multiplied by minus 7. So these are the factors. Then here we write the sum of factors. So the sum of factors here, we can say 9 plus 7, this gives you 16. And here if we say minus 9 plus minus 7, this one will give you, this is the same as saying minus 9 minus 7, this will give you minus 16. So these are the factors which we want, right? These ones. So what we will do is we'll take these factors And instead of writing minus 16x, we'll write minus 9x plus minus 7x. So we form our brackets for the first one, A. We form our brackets, 2 brackets like this. So here, since both brackets are going to produce a product of x squared, it means that both brackets must at least contain x, so that if you multiply this x times x, we're going to get x squared. Then instead of writing our product instead of writing this minus 16, we're going to have one of the factors or one of the brackets containing minus 9, the other one containing minus 7, so that it will be like this: x minus 9 bracket x minus 7. So that if we expand it, this will be x squared minus 9 minus 7x minus 9x plus 63. So this will be the solution. Let's go to the second one, B. Now in this case, this second problem has got a coefficient before x squared and this number here, minus 4. So what we will do is we need to multiply these two factors and then get a factor, and then get, let's say, minus 20x squared. Then find two factors of minus 20x squared, which will give us a positive 1. So for example, for minus 20, I will need minus 20 can be written as minus 5 multiplied by 4. Then minus 20 as well can be written as minus 4 multiplied by 5. The other factors, 10 times 2, are not going to give us 1, so we're just going to stick with these ones. So minus 5 multiplied by 4, so we can say minus 5 here. If we're adding the factors minus 5 plus 4, this will give us minus 1, but our x here is positive, so we need a positive number. So we're going to take this one, minus 4 plus 5, this will be 5 minus 4, this gives us 1. So these are the factors that we want, minus 4 and 5. So we're going to form again our brackets to get our solutions. The first one, what we will do is, since our coefficient, there are no factors which can give us 5, it means that one of the factors has to be 5x and then the other one has to be 5. Then we're going to take one of the 2 to put it here, the other one put it here. So it will be 5x minus 4, and here it will be x plus 5 to get our solutions. Right, I hope this is easy to understand. Then for the last one, alright, now for this one, it's a bit different from the first one that we did there. Now this one will require you to pay a bit more attention so that you can quickly solve it nicely. So in this case, we have 8x squared plus 34x plus 21 equals to 0. What you need to do is you need to break it into groups, to break down your expression into groups. So I have with me here 34x as the middle term here. So what I can do is to find factors of 34x which are a sum of factors of this 21 multiplied by 8. So what I will do is I will break this down into 8x squared plus 6x plus 28x plus 21 equals to 0. Where did I get this 6x and this 28x? Okay, so So what I did was I looked for factors of 21 multiplied by 8. This last term multiplied by this first coefficient gives us 8 here. 8 times 2 is 16. So I looked for factors of 168. So here I'm looking for factors. Then here I look for the sum of factors of 168. Okay. So 21 times 8. 21 times 8 gives me, if I add this one, I get 29. So it's not possible. So I look for other factors. So the next set of factors that I have is if I divide this number by 6. Here I divide by 8. So if I divide this number by 6, let's see if I divide by 6. 6 into 16, 2 remainder 4. 6 into 48, 8. So if I add 28 plus 6, I get 34. So this is the set of factors that I want. So this is why I chose these two factors. So 8x squared plus 6x plus 28x plus 21 gives us 0. Next, what I need to do here is I factorize now this expression. I've rearranged my expression so that it can help me do the work better. You can arrange it in any way as long as there are some common factors. You can put 6x plus 21. It will still give you the same answer. Okay, you will see this in a moment. So here I can have 2x as the common factor. 2x as the common factor. If I divide this one by 2x, my answer will be 4x plus 3. Then here I can have, I maintain the sign here, 7 as the common factor. Then 7 into 28x, 4x. Then 7 into 21, 3. So I add the remaining factor. I first write the common factor, which is 4x plus 3. So 4x plus 3. 4x plus 3 is the common factor. And 4x plus 3 is the common factor. And then I add the remaining factors, 2x plus 7. So this will be the final answer. Now, what I was saying is that it doesn't matter which way you arrange these factors. Even if you start with 28x and you put this 6 here. Let's see, it will be 8x squared. 8x squared. 8x squared plus 28x plus 6x plus 21 equals to 0. There are some common factors here, right? 4. So 4x is a common factor here. 4x bracket 2x plus 7. And then here the common factor is 3. So I maintain the sign plus 3 bracket 2x plus again 7 equals to 0. The common factor will be 2x plus 7 bracket the remaining factors. I get the remaining factors, 4x plus 3 equals to 0. And this will be your answer. Now after this, it's very simple. To solve, to find the value of x, you just equate all the values. Either one of it means if this solution is equals to 0, what it means is either this or this is equals to 0. Why? Because any number multiplied by 0 gives 0. So either this 2x plus 7 is equals to 0 or 4x plus 3 is equals to 0. So you can have 2x plus 7 equals to 0 to solve to find the exact value of x. Then you subtract 7 from both sides. 2x equals to minus 7. Then you divide by 2 from both sides. Then your x is equals to minus 7 over 2 or minus 3.5. Then for the second one, or
4x plus 3 equals to 0. So it will be very simple again. We subtract 3 from both sides. 4x equals to minus 3. Then you divide by 4 both sides. Then x equals to minus 3 over 4. So it means the value for x is equals to minus 7 over 2 or minus 3 over 4. Okay. So here are your solutions for all the problems. Here are your solutions for all the problems.
If you like this, remember to like, comment, and subscribe and share. If you have got problems, ask. Let's dive right into it. In this question, we are given two shapes. We have one which is a rectangle and another being a triangle. The first part requires us to calculate the area of the triangle and the area of the rectangle in terms of x. So the sides of the rectangle M are x plus 4 and 7 minus x. So to calculate the area, we say length multiplied by the width, which is equals to x plus 4 multiplied by 7 minus x. This would give us now x multiplied by 7 and x multiplied by minus x plus 4 multiplied by 7 and 4 multiplied by minus x. So x multiplied by 7 gives us 7x plus x multiplied by minus x equals to minus x squared. 7 times 4 equals to 28. 4 times minus x minus 4x. And then we rearrange the terms. Minus x squared plus 7x minus 4x plus 28. And this would give us minus x squared plus 3x plus 28. So that's the area of the shape M, the rectangle M. For the area of N, it is a triangle. So in order to calculate the area of a triangle N, we say half base multiplied by the height, which is equals to half of 3x plus 1 multiplied by x. This would give us, let me rewrite that, half of 3x plus 1 multiplied by x. Okay, so this would give us half of 3x squared plus x, which can also be written as 3x squared plus x all over 2. In the next part, we are given that the area of N is equals to 3x squared plus x over 2, and we already calculated the other area. So given that the area of M is 2 times the area of N, show that it reduces to 2x squared minus x minus 14. So minus x squared plus 3x plus 28 is equals to 2 multiplied by 3x squared plus x over 2. This would give you minus x squared plus 3x plus 28. The 2's cancel out each other, leaving 3x squared plus x. And this will lead you now to minus x squared plus 3x plus 28 equals to 3x squared plus x. Then we bring the like terms together on one side. So let's bring the terms with x squared and x on one side. So that will give us minus x squared and 3x squared. So we're going to remain with 28 this side and put all the terms with x on the other side. 3x squared plus x squared. 3x squared plus x squared plus x
minus 3x. So this will give us 4x squared plus x minus 3x, which gives us minus 2x, and 28 equals to 4x squared minus 2x. Then we bring all the terms to one side so that we can equate to 0. And this will now leave us with 4x squared minus 2x minus 28 is equals to 0. And we can divide all the terms by 2 since 2 is a common factor there. So if we divide everything by 2, we're going to remain with 2x squared. So we're going to divide for every term. We're going to remain with 2x squared minus 2x minus 28 so 2 divided by 4 divided by 2, 2 divided by 2, 1, 20 divided by 2, 14, and therefore we're going to remain with 2x squared minus x minus 14 equals to 0, and hence it becomes similar, or it's the same as that one which we've been given. So we've shown that it reduces to that. Now we're going to move on to the next part of the question, which requires us to solve for the value of x. Since we've already found a quadratic equation which is which links both the areas, we're going to have to try to solve it and find the value of x. In this case, it will be difficult to use other methods like completing the square and regrouping, and the graphing method is still okay, but the best method to use in this case would be the quadratic formula. The quadratic formula or the quadratic equation is the one which is going to help us to get answers in a more quick and easy manner. So the quadratic formula is read as such: x is equals to minus b plus or minus the square root of b squared minus 4ac and all over 2a. So the values now of b, a, and c, we're going to get them from the equation. The value of a is 2. So the values of a, b, and c are the coefficients of the values or the unknowns. The value of a being the coefficient of x squared, the value of b being the coefficient of x to the power 1, and the value of c being the coefficient of x to the power 0. So it will read x is equals to minus 1 plus or minus square root of minus 1 squared minus 4 multiplied by 2 multiplied by minus 14 all over 2 times 2. This would give us 1 plus or minus 1 plus 112 all over 4. Alright, so this would be 1 plus 112 over 4. Then this will lead us to 1 plus or minus square root of 113 all over 4. Now, to calculate the square root of 113, we're not going to crack our heads. We're going to use a calculator, which will make our work easier. So here I've separated the equations. So the value of x could be 1 plus square root of 113 over 4, or the square root of, or 1 minus square root of 113 over 4. So I'm going to use a calculator. So we got the square root of 113 is 10.63. So it will be 1 plus 10.63 01 over 4, or 1 minus 10.6301 over 4.
and this will lead us to 11.6301 over 4, or minus 9.6301 over 4. Now we only need to divide again. We're going to have to use a calculator. So I've gotten my values there. Alright, so back to our equation. So the value x is equals to 2.9 or minus 2.4075. So to three significant figures, both of these numbers, x can be equal to 2.91 or x equals to minus 2.41. However, we're not going to consider the negative value, since if we're looking at a real value or a real quantity such as length, we only take the positive value. So we're only going to consider the 2.91. Okay. So we only use the positive root because the length of the shape is a real quantity. Alright, so now we're asked to find the then we round off to the nearest millimeter, which we are going to get is 69 millimeters. Alright, so this marks the end. Don't forget to like and to subscribe. Stay tuned for more. If you've got any questions, feel free to ask in the comment section. See you next time. Hello, good day. We are going to look at our topic, adding and subtracting algebraic fractions. So we should appreciate the fact that an algebraic fraction is any fraction that has got unknown variables or letters, like we are talking about algebra. So for example, x over 4 is an algebraic fraction, 2a over 3, b over 2, those are all examples of algebraic fractions. And today we're going to look at how to simplify simple algebraic fractions using some of the methods that we've already looked at. Okay, so for today we're only going to be looking at addition and subtraction. So I've pre-selected number 1a from exercise 9.6 on page 93 in our learner's book or in our course book. Number 1a, 1b, 1j and 2c. So we'll start with 1a there. 1a says x over 5 plus x over 5. So 1a is x over 5, x over 5 plus x over 5, x over 5, like this, right? So when we have got two fractions with the same denominator like this, it's very easy. what we simply do is, in the answer, we only need to maintain the same denominator, and our denominator here is 5, so we maintain our same denominator there, and we maintain our denominator 5, which is being 5 like this, okay, and we move on to let me just write 1 5 like this, okay, and then our numerator is going to be 5. Our numerator is going to be x plus x, or 1x plus 1x, which gives us 2x like this. So x over 5 plus x over 5 is equals to 2x over 5. Let's go to number B. Number B says x over 7 plus 3x over 7. So x over 7, x, what this looks like in x, okay, let me take that one again, x over 7 like this, plus 3x over 7, 3x, okay, let me erase this one, plus 3x over 7, okay, equals, so here again we have the same denominator, so it's not a problem. We are going to just continue the same denominator, and then for us to correctly work this one out, we just need to add the numerator as 1x plus 3x, which is equals to 4x, like this, 4x over 7, okay. Let's try a different one, or another problem where there are different denominators. J says y over 2 minus y over 8. Y over 2 minus y over 8. Y over 2 minus y over 8, like this, right, equals, so since here you can notice that 2 and 8 have different denominators, or are different, the denominators are different, the first thing that you need to do is to find the common denominator. In this case, the lowest common denominator, or lowest common multiple, would be 8. So we maintain this 8. Then what we do now, 2 into this 8, we get 4. 4 times y gives us 4y. I'm going to put like this, 4 bracket y, okay. I'll extend this line as well. Let me not extend it in this way. Let me continue writing. So 4y, we maintain this minus, and then 8 into 8, that's 1. 1 times y is simply going to be y like this, right? So it is the same as saying 4y minus y like this, which we should have done simply in the first step, but I wanted to put it that way. And then 4y minus 1y is equals to 3y like this, and the denominator remains 8. Okay, like that, right? And then the last one is number 2c. Number 2c, it says 5c over 7 minus 2c over 5. Okay, so it wants us to show all the steps, so we're going to show all the steps as required. It says 5, let me write it like this, 5c over 7, right, minus 2c
2c over 5, like this, equals. So here you can notice that the denominators are different. So what should we do? Instead of, if we don't have time to look for the lowest common multiple of these denominators of 7 and 5, the simplest way would be just to multiply the denominators, okay? So the product of these multiples, also of the multiple, set of the product of these denominators of 7 and 5 will give us the lower or the common denominator, which is 7 times 5 equals to 35, alright? Now we erase this 5 so that I write it once, so that the computer can recognize like this. 35, alright? Yes, 35, like this, right? And then the numerator, it's to get the numerator, we now divide 7 into 35, we get 5, so it will be 5 like this, bracket 7 into 35, this is this 5, and then we multiply by the numerator there, so 5 bracket times 5c, then we put this minus 5 into 35, that's 7, so we put our 7 there, and then 7 is going to multiply 2c like that, okay? 7 multiplying 2c. I'm going to just quickly correct this section, okay, like this. So it's 5 bracket 5c minus 7 bracket 2c. Then the next stage is we want to solve this one. So 5 times 5, this is 25c, like this. Then 7 times 2 is minus 14 here, minus 14c, like this, right? Okay, what's happening there? Let me erase here so that okay, right, I'll continue writing in front here. I'll continue writing, I'll stretch our board like this, right? So this is equals to 5 times 5, we got 25c like that, 25c, 25, not x, c please, c. Then here we maintain the sign, 7 times 2, 14c over the common denominator 35, like that, alright? Then we do the operations. 25 minus 14, that's 11c, then over 35, over 35, over 35, like that, over 35. Okay, 11c over 35 here, let me correct here on top. Okay, 11c, like that, 11c, 11c, this is not a K computer, I want 11, and then a C, like that, yes, 11c over 35. Okay, so if you've got any problems, just highlight and we'll see what we can do to help.
You won't believe the problems I came across in the restaurant.